So here's what I really want to do. I'm going to use those in a second, but I kind of want to show you just the fastest way to graph this. So here's how you should really graph sine, or any sine or cosine function. There's 5 points you want to graph. Always 5 if we're graphing one full period. So we're graphing y cosine x, we're graphing one full period of it. So we're going to use all the quadrantal angles. Those are the points that are the nicest to graph, that tell us kind of all the information we want. So I look at my nice little unit circle here, where the points are 1, 0, 0, 1, negative 1, 0, and 0, negative 1, corresponding to the angles 0, pi over 2, pi, 3 pi over 2, and then back all the way around to 2 pi. We're going to use those 5 angles along with the 5 values that we use for the sine function to graph this thing. So here's how I typically do it. I kind of draw the whole length of my period, and then I'm going to cut this into 4 equal quadrants. I'm going to cut it in half, and then each of those in half again. So that the halfway point is pi, and then this is pi over 2, and that's 3 pi over 2. My y scale is probably going to be a little bit larger than it needs to be just to make the graph look nice, right? 1 is probably about there. I like to move it up just a little bit just to make it easier to graph the thing. So I'm just going to go around the circle. At 0, sine of 0 is 0. At pi over 2, sine of pi over 2 is the y value, which is 1. At pi, sine of pi is 0. At 3 pi over 2, sine of 3 pi over 2 is negative 1. And at 2 pi, so here's the thing. Once you've gone a full revolution, you should always get back to the value you started at. So if I started at 0, I should definitely end at 0. You can also see that, right? If you look at 2 pi, the y value, the sine value is 0. And then we try and draw it so it looks like a sine function or a cosine function, meaning it should be kind of, it should be smooth. It should have a nice kind of sinusoidal shape is actually the word. It's going to look like this. So if you were going to be real specific about it, there's exactly 1 period. I started at 0, I ended at 2 pi. Typically, I draw little arrows like this to indicate that the graph keeps on going. So when I graph a trig function, I am most concerned with making sure I have these 5 points. The beginning point, and then 1 more point every quarter. So this top point, this middle point, this bottom point, and this middle point. I'm always looking for the highs and the lows and the middle points. So that's how I would graph sine. You could graph more points, right? Like you could say, well, I know that sine of pi over 4 is root 2 over 2. But I don't really need you to do that for me. I really, if I'm asking you to graph sine or cosine of anything, I really just want to see the beginning, the high, the middle, the low, the middle. And we'll kind of see a pattern for how these always look. There's something that always kind of happens, whether it's sine or cosine. So let's go ahead and flip it around and graph cosine. So I know I said I was going to use those values. I'm not really going to use those values. I almost never use those values. So I was going to graph cosine of x. Again, 1 period's worth. And the reason we specify 1 period's worth is because after 1 period, you just get the same graph. In fact, just to kind of show it off, I'll actually graph 2 periods worth, just to kind of show you that it just repeats. So again, same idea. I'm going to use my unit circle, which I don't think I really need to draw again, but I'll just draw again, right? The points are 1, 0, 0, 1, negative 1, 0, 0, negative 1. Someone just came in. Here we go. And hopefully this looks it looks kind of crooked. Sometimes my lines aren't super straight. So I'm going to go 1 period's worth is 2 pi. And again, 1 period is 2 pi because that's 1 full revolution. Once you go around the circle 1 whole time, you're just doing the same stuff, right? The cosine values just repeat every full revolution of the circle. But say, so cosine of 0 is 1. Sorry, I forgot to cut this in half. So cut this in half, and then in half again. There's pi over 2, there's 3 pi over 2. So cosine of 0 is 1, right, because it's the x coordinate. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is all the way back where we started, back to 1. And so this one looks kind of like this. And then you could do another period if you want, right? If you keep going, cosine of 5 pi over 2, we just keep going around the circle, is 0 again. Cosine of 3 pi is -1 again. Cosine of 7 pi over 2 is 0 again. And then cosine of 4 pi, is 1 again. So it just does the same thing. So it's really not necessary to draw any more than this because this tells you everything that happens. After that, it's just kind of a repeat. Sorry, it's kind of go ahead and hold this there. So that's what cosine of x looks like. And as you might observe, cosine and sine have a very similar shape. So, oops, I'm dropping things. I did also want to show you, so I think it's important that you're able to graph these things, right? There are definitely things that come up relatively frequently. We need to know what their graphs look like and have a good idea without having to kind of use some outside resource. That said, we have a lot of outside resources that are helpful. So, and my drawings, although decent, are not perfect. Whereas, let me share here. Sure. If we look at Desmos, which is a graphing utility, so I encourage everyone to use Desmos. I do want you to try and graph things on your own, but you can definitely check Desmos as well. If you so I plugged in the function y equals sine of x, right? I typed out y equals sine of x, and then I also limited my domain here. So if you want to just see part of the function, you can specify that x is between 0 and 2 pi. So I can erase that, and then there's the whole thing. Can zoom out and see that it just goes on and on and on and on and on. If we zoom back in, we can also click on some points. So like this point right here, right, there's 0, 0. And that point right there, there's pi over 2, comma 1, and pi, comma 0, and 3 pi over 2, -1, right? Those are kind of the typical points, which is kind of nice that it gives you those. So those are the usual points you would look for if someone was graphing sine of x. And then if you want to see, because I think this is nice to know, if you want to see how to restrict the domain, all you do is you type a brace. Oops, try it again. You type a brace, then you put your lower bound, so 0, then you type the less than button and then the equals button to make it a less than or equal to, and then x, and then again less than, equals, and then 2 pi, and then close the brace, and that'll restrict your domain. Not that you have to restrict it, but it just kind of shows you what the graph looks like on that restricted domain. We also have right next to it, I also graphed cosine just so you guys can see it. So here is y equal to cosine x. Again, I restricted the domain to be between 0 and 5 pi. So from 0 to 2 pi, we have 1 full period, right? The graph does the thing it does. And then from 2 pi all the way to 4 pi, it does the same thing, right? That's a whole nother revolution. And each subsequent 2 pi, right, I could make this go out to 6 pi, gives us another, can I do this? No, I have to zoom out. Gives us another full period. So, right, there's 1 full period, there's another full period, doesn't want to let me click on that button for some reason. I don't know why. The point should be there. It's not. It's bothering me that it's not. So that's how we graph sine and cosine. That's not all we do with sine and cosine, but that's kind of the beginning. So let's see if there's anything else I want to say. Oh yeah, so here's what I think about when I'm graphing sine. So when I'm graphing sine, I think about that sine starts in the middle, right? So I think about this graph having a range of +1 to -1, right? It goes as high as 1, it goes as low as -1. Sine starts in the middle, and then the next important point is the high point, then back to the middle, then the low point, then back to the middle. And sine and cosine always kind of have this nature where they go to an extreme, and then they go back to the middle. Extreme, back to the middle. Extreme, back to the middle. Extreme, back to the middle. Right? We just go on, no. Okay. We won't go on, no. But cosine does it too, right? Top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle, right? It's always top, then middle, then bottom, then middle, then something, then middle, then something, then middle, then something, then middle, right? You're always going one or the other. It's always true for sine and cosine. So if you know what the top and the bottom are and you know what the middle is, you can always graph them relatively quickly. But sometimes what changes is where the middle is and where the top and the bottom are. So what I'm going to kind of model for you guys is I think you should try graphing things on your own. And then after you graph the thing, try looking at Desmos to see if maybe you've gotten it right, or maybe you need to just fix a little bit. So I think it's perfectly fine to use Desmos as kind of a check, but I really think it's important that you're able to think about graphing these things on your own without using Desmos to start, or whatever graphing utility you might want to use. Desmos is nice though because it has a lot of functionality. So, whoops, okay, smooth. So there's a couple things that we can change about our graphs. Notably, here we're going to talk about changing the amplitude and the vertical shift. So amplitude first. So for y equal to a times sine of x, or y equal to a times cosine of x, we have some coefficients out here. The amplitude, which there's a couple ways to think about what it is. I think about it as, which is how far from the middle the highs and lows are. So just to kind of go back for a second, for y equals cosine x, the amplitude is 1 because the middle is at 0. The highs are 1 away, 1 above, and 1 below. Another way to think about the amplitude is it's half of the length of the range. So here the range goes from -1 to 1, which is a length of 2, and half of 2 is 1. But it's easiest just to see that the amplitude is whatever the coefficient out in front of the function is. So this function has an amplitude of 1, so did sine of x. So the amplitude is given by, well, I should say, it's not actually the coefficient out there, it's the absolute value of the coefficient. Because you could have y equal to like -2 times sine of x, and we would still say the amplitude was +2. And amplitude is always a positive thing. So let's look at a couple examples. I'm going to change that example. Also, please feel free to chime in with questions if you have them. So let's say we're going to graph y equal to 3 times sine of x. And normally what I would do is say, okay, I know I'm going to take my regular sine graph and stretch it vertically by a factor of 3. I look like I'm a magician, like look at this. But I'm not. I'm a mathematician, not a magician. Anyway, so the way you can actually see this numerically, make a little table with the values for x, sine of x, and 3 times sine of x. We're going to pick the usual angle values. So whenever you're thinking about graphing a trig function like sine or cosine, your usual angles are the quadrantal angles. 0, pi over 2, pi, 3 pi over 2, and 2 pi. We know that sine goes middle, high, middle, low, middle, which is the middle is 0, the high is 1, the middle is 0, the low is -1, the middle is 0. And then 3 times sine of x, we're just going to multiply all those by 3. So 0 times 3 is 0, 1 times 3 is 3, 0 times 3 is 0, negative 1 times 3 is -3, and 0 times 3 is 0. So we've just taken our highs and our lows and made them higher and lower. I don't think you need to make this table. I'm just trying to show you how you can see that it's going to be more extreme. So, sorry, one sec. So again, when I'm graphing this, I start by kind of going, okay, there's my period length, cut it in half, cut those each in half. Sometimes I don't even label the rest of these. And then the way I usually kind of do my scale is I'm like, okay, pi is about 3, so okay, that's about 3. Your scales do not have to be the same on the x and the y-axis. They can kind of be whatever is most convenient to graph. All right, sine, middle. And then at the next important x value, which is pi over 2, we go high. And then at the next important x value, we go back to the middle. And then since we were high and then we went middle, then we have to go low next. And then back to the middle. My drawing is just okay. It could be better. Your drawings don't have to be perfect. Mine never will be. I don't expect yours to be either. I do expect you to have the general gist of the shape and to try not to make it too pointy. Right? Because these graphs should have nice kind of curves that are smooth and not jagged or cuspy. So here, you would say that the amplitude is 3. And when your amplitude is larger than 1, it's going to stretch out the trig function vertically. You might also recognize this as what's called a vertical stretch. Let's do another one. And if I need to slow down, let me know. Oh, I know, but I did want to show you. So then, if you wanted, go back real quick. We could then check out Desmos and be like, well, how does this look? Like, did I do a good job? Let's take a look. So if we go back to Desmos, if I make it 3 sine of x, yeah, it looks all right, right? I mean, it looks pretty close to what I did, maybe not exactly the same. And you can see the important points, right? These little gray points here, 0, 0, pi over 2, comma 3, pi 0, 3 pi over 2, -3. And 2 pi 0. If you click on them, they stay there so you can kind of see them, which is nice. Okay. So I want to show you another one. Oh, I will also point out, just in case everyone's curious, right? So if you want to think about the amplitude as half of the length of the range here goes from -3 to 3, which is a length of 6, and half of 6 is 2. Half of 6 is 3. Sorry. Okay. Half of 6 is not 2. Sometimes I say dumb things because my brain is already thinking of the next number I want to say, and I've forgotten the one I was going to say. So let's try graphing this. Y equal to -1/2 cosine of x. So the thing I want you guys to know for this problem is the amplitude is +1/2. The amplitude is always a positive number. And so what's going to happen is, since the amplitude's smaller than 1, it's going to smoosh it down, right? We're only going to go up as high as 1/2 and down as low as -1/2. It's called a vertical compression. I like to say it's a vertical squish, but compression is the more efficient term. Okay, so there's my usual points. And I'm actually going to graph regular cosine for you guys first. So right here, let's see, that's it. There's maybe 1. So here is regular cosine coming at you. It starts at 1, then hits 0, then hits -1. And so when I'm saying then, right, whenever I'm going to the next value, it's always the next quadrantal angle. So I'm going from x equals 0, I get 1. Then x equals pi over 2, I get 0. X equals pi, I get -1. X equals 3 pi over 2, I get 0. And x equals 2 pi back to 1. So there's regular cosine of x. Oh, I'm going to show you guys this. Nail's cool on Desmos. So then I'm going to graph this. Now, the 1/2 is going to smoosh it down. And the negative, when you multiply a function by a negative, it flips it over the x-axis. So instead of starting at +1/2, I'm actually going to start at -1/2. Which makes sense, right? If you take 1 and multiply it by -1/2, you're going to get -1/2. And then, so just like before, and now I'm at the bottom, and then the next one's going to be at the middle, and the next one's going to be at the top, and then at the middle, and then back to the bottom. Nope, so 2 pi is kind of in the way. So it kind of looks like this. One of the things I'll say, when you graph these, when you're coming towards the point that you know is the top, you want to start kind of slowing down, right? So you're like, oh, I'm getting close to the top. I want to hit the top and then start going down right after. I definitely see lots of people graph these where they're like, oh, like this, like they kind of overshoot. So think about that when you're graphing it, right? So that you can be like, oh yeah, I'm getting ready to turn around so that the top really is the top. What else do I want to say about this? So whenever you have a negative again, right, it's always going to flip it over. And just, I'm not going to draw it, but I'll just say that if you had -3 sine of x, it would just be this graph. Well, I can draw it, why not? Here's what -3 sine of x would look like. Right, it just looks like this graph got flipped over the x-axis. So another neat thing about Desmos, I'm a fan of Desmos, in case you didn't know, is that you can do more than one graph on the same thing. So here's our y equals cosine x, and then I can also graph y equals -1/2. And then I want to move, so if I just write cosine now, it's going to be a problem, right? It's going to end up in the bottom. Did you guys see that? That seems not good. That's a weird, that's not what I drew for sure. I'd be like, oh, that looks really wrong. I need that to not be in the denominator. So I need to cursor over with the arrow, and then I'm no longer in the denominator. And I can say, oh, now I need cosine of x. And then we can see, oh yeah, so my colors are kind of switched. Right, so you don't get, I don't think you get to pick the colors, unfortunately. I think they pick for you. My black function is their red function and vice versa, which is just a coincidence. I think maybe if you click on this, you can pick the color. No, you can't. You can turn it off or turn it on. So there's my -1/2 x, which definitely looks like this one here. And then, right, there's my regular one. That's kind of neat that you can turn them on and off like that too. All right, so let's now talk about vertical shifting. So vertical shifting is a little bit, I think it's actually a little easier. So amplitude's kind of like, it's all right. Vertical shifting is, sorry, pressing buttons. Okay. Yeah, I'm definitely, so I think I'm probably not going to get through everything I wanted to say today. Here's what I'll say about the homework that's due next Tuesday. Don't do any of the tangent or secant stuff or cosecant stuff or cotangent stuff unless we get to on Monday, which I don't think we're going to get to on Monday. So I'll probably just cut that from the homework. I would say, don't worry about that stuff. We'll get to it later. Because I've got a lot of examples I want to get through, and I feel like it's important to get through them. But you guys should definitely start working on graphing the sines and cosine stuff. So I want to graph y equals the sine of x plus 2. So that plus 2 is just going to add 2 to every y value. So normally, right, here's my normal sine function. Right, where it's middle, high, middle, low, middle. This is y equals sine of x. Maybe I should have picked a different color. And then the plus 2, all the y values are just going to be 2 more than they were. So the way I like to draw this is I like to draw a new horizontal middle line. So if you don't have a vertical shift, your middle line is just the x-axis. If you have a vertical shift, your middle line is whatever that value is. So my new middle line is going to be positive 2. So here's what I like to do. I like to draw a straighter axis. So 1, 2, 3. So that's my new middle. And then sine's just going to do the same thing it usually does. It's going to go middle, high, middle, low, middle. So now the middle is 2. What's the amplitude?
1.
Yeah, thank you. So I'm going to go, so that's why I said before the amplitude is how far you move from the middle. Because once I start at the middle, then I'm going to go up 1 to 3, and then back to the middle, and then down 1 to 1, and then back to the middle. So it looks just like this graph, just the whole thing is shifted up by 2. Yeah. And so, yeah, we can see, I mean, I like looking at Desmos. I'm not gonna lie. Desmos is a great tool. I would use it all the time. So definitely after you graph things, feel free to be like, how does this look on Desmos? So here is our regular sine function. And now I'm going to draw another one where it's that function shifted up by 2. So sine of x. Now I'm going to make a mistake right here. I accidentally put the plus 2 inside the sine function, and it didn't shift it up. It actually shifted it to the, well, it's hard to tell because I have, let's see, let's copy that. It shifted it a little bit to the left, it looks like. No, to the right, I don't know. Anyway, it's not what I wanted, right? I need that plus 2 to be not inside. I need it to be outside. And then we can see, oh yeah, totally shifts it up 2. Not a long time, okay. So then we can put it all together. For example, we can graph something like y equal to 3 times sine of x plus 2. So I'm going to write down the important information. I should probably stop sharing my screen so you guys can see. If I'm ever sharing my screen, you guys are like, stop, just say words. So the amplitude here is 3, and the vertical shift is 2. I would also point out that we usually like to state the period. The period is 2 pi. The period's always going to be 2 pi until we start multiplying stuff by x, which we are not doing yet. So for now, sine or cosine, the period is just 2 pi. Okay. So, let's see. I know most of you probably haven't looked at the next homework assignment yet because it wasn't available until a couple hours ago. But if you look at it, you will notice that a lot of the so if you're obviously welcome to draw these on your own paper, but if you draw it on the paper that I provided in the handout, you'll notice that the coordinate system is sometimes like weirdly shifted up or down. That's because like if you see that the x-axis is way down low, it means that most of your graph is like up here. Or if your x-axis is way up high, it means most of your graph is down below the x-axis. So that's why the coordinate systems I provided might look a little bit odd, because they're trying to give you room where you actually need it. Okay, where's my new middle line? Maybe I should draw some points. You guys can say it or type it.
Is it 2?
It is 2. So here's the thing. When I'm drawing this, my setup is always going to be go to the middle. Here the middle is 2. And then make sure you have an amplitude's worth above and below. So I need to be able to go 2 and then up 3 to 5, 2 minus 3 down to -1. So from the middle to the top, that's the amplitude. And from the middle to the bottom, that's the amplitude. You don't have to write this out. I'm just trying to be explicit. And then sine starts in the middle. Oh, I need to also write out my period. So this is where you can kind of be not to scale, right? This length is 6, which is about a period, right? A period is 2 pi, which is 6.28 approximately. If I try and take that and do it down here, I really want a little more room than that. So I'm just gonna make my period like out to here. Your scales do not have to be the same for the x and y. I know I'm saying this more than once because it's mildly. Okay. So there are my right, 0. There are my 5 important x values: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm just going to draw the usual sine graph. So I'm going to start at the middle. And then I'm going to go up to the top. And then back to the middle. And then to the bottom. Now be careful. Going to the bottom here is where a lot of people like to stop at the x-axis. But the bottom is down here at -1. So let me make a little more room there. Sometimes the numbers you write get a little in the way. It's just a fact of life. So middle, top, middle, bottom. I'm at the bottom and go back to the middle. And the only points that I really care about you telling me that you know are on this graph are those 5 points. This middle point at 0, 3. I don't even think you need to really write them out. I'm just showing you them. This point here at pi over 2, sorry, 0, 2, sorry, 0, 2. This point here at pi over 2, comma 5. This point here at pi, comma 2. This point here at 3 pi over 2, comma -1. And this last point at 2 pi, comma 2. Those 5 points are the only ones I feel like you have to have on your graph. Anything else is unnecessary. Specifically, you do not need to tell me what these x-intercepts are. Those are not typically required unless they happen to be where one of these 5 points lives. Okay. What time is it? Oh, wow. Time is really going by. I have a lot to say. So let me do as many more examples as I can. I will say there are some examples in the notes that I will post that we're not going to get to today. There's still good examples to look at if you have like, if you want to see something else. So let's see. Okay. I want to make sure I get two things. Okay, let's do this one. So let's do y equal to, I'm going to change it up a little bit. Let's do 2 cosine x minus 2. Okay, so my amplitude is 2. My vertical shift is -2. And my period is still 2 pi. So I'm going to be shifting down 2, so I probably want to be, I want to have more room underneath the x-axis. So here's my new middle line at -2. And then I know that I need to be able to go 2 above, so up to 0, and 2 below, so down to -4. Typically, when I'm writing values on the y-axis, I only write the values of the high, middle, and low. I don't write any other numbers usually. You certainly can, but you don't really need to. So then, unlike sine, cosine doesn't start at the middle, cosine starts high. Oh, but I need my period, sorry. So there are my usual 1, 2, 3, 4, 5 important x values. And then cosine starts high. And then if you're high, the only place you can go is to the middle, right? It's high and then to the middle. And then if you were high and you went to the middle, then you have to go low. Right? It's always this kind of back and forth. High, middle, low, middle, high, middle, low. What's the song? Low, high, middle, low, middle. Okay. Anyway, I know it's super entertaining, but I will stop because I know you guys can't contain yourselves. Also, I mean, hopefully me dancing doesn't ever end up where anyone really can see it, but you never know. So high, middle, low, middle, high. There's cosine. Oops. Okay. So see how I kind of like overshot that a little bit? Let's fix that. And here, right, this is the top, so I have to be turning around when I get there. So in this particular example, your high starting point and your high end point are on the x-axis. So those x-intercepts should be included because they're one of your 5 important points. Okay, let's do one more. Not you. Yeah, fine, you. You're the one, I guess. And again, if you have the time, which I think you do, I would certainly look at Desmos to see kind of how these look. In fact, I have the time. Let's take a look real quick. So if we put this one on Desmos, show screen, Desmos it up. So, all right, if we delete this. So I've got y equal to 2 cosine of x minus 2. So that'll give me the whole graph. And then I can see, okay, I'm starting at 0, 0. Now it's not giving me that middle point that I usually like to have, right? Just kind of giving me those points. And maybe if I zoom in a little, I want, that's interesting that it doesn't give me that point there. I want the point, it's not giving it to me. Maybe if I change my domain a little, 0 less than or equal to x less than or equal to 2 pi. It doesn't want to, sometimes it doesn't want to give you all the nice values. I don't know why. Maybe if we zoom in more. Nope, I don't know. Sometimes it's just finicky, I guess. I can't say why it's not giving me all the wonderful values I want. But it is giving me the same picture, right? We're definitely going high, middle, whatever value that happens to be. It's pi over 2 comma -2, and then pi comma -4. And then 3 pi over 2 comma -2. Finicky little thing here. And then 2 pi comma 0. Yeah, I don't know why. Sometimes things are not as nice as you want them to be. Okay, last one. I got 3 minutes, plenty of time. So the last one I want to do is, so I want to point out that sometimes when you have a negative thing, I know, I will stop sharing my screen. Sometimes people like to write it like this. Like if you have a vertical shift and a negative coefficient for your trig function, people like to write it like this. You can't do 3 minus 2 is 1. That's not okay. What we can do is we can rewrite it as -2 sine of x plus 3. So that it's a little more clear. Oh, I have a vertical flip because of the negative. My amplitude is +2 because it's just the coefficient without the negative. And we have a vertical shift of +3. So that's all the pertinent information. Now we are going to draw it. Of course, the period. So on Monday, we'll talk about sine and cosine functions where the period is something other than 2 pi. So I probably need to give myself enough vertical room. I'm going to erase this. Right down here. Actually, it's written over there. I don't need to erase it. I don't need to rewrite it. Perfect. Because I know that I'm going to go up 3. There's my new middle line. And then I have to have, so my amplitude is 2. So I have to be able to go 2 above it to 5 and 2 below it to 1. So those are my high, my middle, and my low. And then, well, not usually, sine starts out at the middle. Sorry, forgot my period. Period, period, period. Okay, so there are my usual 5x values. Those are going to change when we start changing the period on Monday. But for now, that's what we got. So sine starts where? High, middle, or low. You can write H, M, or L in the chat if you want. Or you can say words. Oh, there's bugs about light. There's
At 3?
There's a lot of bugs up there. Sorry, what'd you say?
At 3?
Yes, or as I would say, in the middle, but definitely at 3. And then usually sine would go high, but since it's a negative, it's vertically flipped, it goes the opposite way it would usually go. So sine starts in the middle, and then we're going to go low, and then back to the middle, and then high, and then back to the middle. Once you know where you start and where you go next, you pretty much got the whole thing figured out. Because once you are in middle and then you go low, then you have to go middle, then you have to go high, then you have to go middle, then you have to go low. Right? It's all kind of predetermined once you know the first couple steps. And then we just do our best job to draw it. That could be better, but you know, so could a lot of things. That's a little better. This one doesn't cross the x-axis at all.